Hello everyone, we are moving on to simultaneous equations in chapter 3. So when we solve simultaneous equations, we are essentially calculating the coordinates where graphs intersect. So these could be two straight lines, a line and a curve, or two curves. And we could solve these equations graphically, but for accuracy, an algebraic approach is better. So let's just actually recap the graphical method. And here we have two straight lines. This line is x plus y is equal to 4, and this line is y is equal to x plus 1. We can see the intersect here, and it looks like x is equal to 1.5 and y is equal to 2.5. So I could write that as a coordinate 1.5, 2.5. We have a look at another one. We have a quadratic and a linear this time. So the quadratic function is y is equal to x squared minus 4, and the linear function is y is equal to x minus 2. And you can see that they intersect in 2 points this time. And I could probably still give a good accurate solution here. So x is equal to 2, y is equal to 0. And here we're pretty much on that line. So this one would be x is equal to minus 1 and y is equal to minus 3. But let's have a look at this one. We've got a circle and a line this time. Now you can see that the intersections are drawn, but have a look. I'm going to be estimating where that point is and where that point is. And I don't think my solution is going to be as accurate as it would be if I'd solved this algebraically. So let's have a look at how we solve simultaneous equations algebraically. So first of all, I'm going to look at linear simultaneous equations and the elimination method. So you may remember this from GCSE. I'm going to label this equation as equation 1 and the second equation as equation 2. And the elimination method is making sure that we have either the x terms the same or the y terms the same and eliminating them, so then we can work out the other variable. So I'm actually going to get the y's to be the same. So I'm going to multiply equation 1 by 2. So I can have 2y here. So I'm going to say what I'm doing. 1 multiplied by 2. So I'll get 4x plus 2y is equal to 8. And I'm going to name that 3. So now I've got a minus 2y in equation 2 and a 2y in equation 3. So if I add equation 2 and 3 together, the y's are going to cancel. So 2 add 3, I'll have 7x is equal to 14. And then when I divide by 7, x is going to be equal to 2. So now I've got x, I can find y. And I'm going to use equation 1. So I'm going to say sub into 1. So I'll have 2 multiplied by 2 plus y is equal to 4. Well, that's 4. So when I take 4 from both sides, I'll actually have a 4 minus 4 here. So y is going to be equal to 0. And if it asks you to find the coordinate, I could write my final answer as 2, 0. Let's move on to another example of the elimination method. So this time I'm going to get the x is the same. I'm going to choose to multiply equation 2 by 3. So I'm going to write this here, 2 multiplied by 3. So I'll have 3x plus 12y is equal to 51. And I'm going to call that 3. Now I want to eliminate the x terms, and the way I can do that is by taking these equations. So if I do 3 take 1, I will get, well, these will cancel, then I'll have 10y is equal to 30. So y is going to be equal to 3. Now I'm going to substitute my value of y into one of these equations, and I'm going to choose equation 2 because the x is 1x, so it's easier to find the solution. So I'm going to have x plus 4 multiplied by 3 is equal to 17. Now 4 multiplied by 3 is 12. When I take 12 from both sides, I'm going to be left with 5 on the right hand side. So x is equal to 5. I've got what y is equal and what x is equal. If it asks you to write as a coordinate, it will be 5, 3. Let's move on to a final example of the elimination method. Now for this one, it looks like I'm going to have to multiply both equations by something. So either the x term or the y term is the same. I'm going to choose to make the y's the same, and I'm going to multiply equation 1 by 2 and equation 2 by 3. So I get 6y for both. So 1 multiplied by 2, I'll have 8x minus 6y is equal to 22. And I'll call that equation 3. And then 2 multiplied by 3, I'll get 9x plus 6y is equal to 12. And I'll call that equation 4. Now, because I've got a minus 6y here and a 6y here, I can add equation 3 and equation 4 together. So I'll have 17x is equal to 34. So dividing by 17, x is going to be 2. Now I can substitute. I'm going to substitute it into equation 2. So sub into 2. So I'll have 3 multiplied by 2 plus 2y is equal to 4. Now this will be 6, so when I take 6 from both sides, I'm going to have 2y is equal to minus 2. And then when I divide by 2, I'll have y is equal to minus 1. So as a coordinate, it will be 2 minus 1. So we have another method that you may remember. It is called the substitution method. So rather than eliminating a variable this time, I'm going to substitute one variable in. So what you're actually looking for in this method is a variable that is a single variable, if you like. So here I just have one y. So if I rearrange equation 1 to have y as the subject, so y is equal to something, then I'll be able to substitute what y is equal to into here. So I'm going to explain what I'm doing. Rearrange equation 1. So I'm going to move this 2x over to the other side by minusing 2x. So I'll have y is equal to 4 minus 2x. Now I'm going to sub this into equation 2. Because wherever I see a y now in the equation, I'm going to replace it with this expression. So 3x minus 2 multiplied by 4 minus 2x, and that's equal to 6. And the reason why this works is, as you can see, we have no y's now. I just have x terms. So when I collect terms and sort this out, I'll be able to find what x is equal to, and then from that I can find what y is equal to. So let's expand. I'll have 3x minus 8 add 4x is equal to 6. Let's combine the x terms together and move this minus 8 over to the other side. So I'll have 7x is equal to 14. Divide by 7, I'm going to get x is equal to 2. So now when x is equal to 2, I'm going to substitute it into here to find what y is equal to. You could substitute it into one of these, but this is already in a nice form because I'll find out what y is straight away rather than having to rearrange to find y. So when x is equal to 2, y is equal to 4 minus 2 multiplied by 2. Well, 4 minus 4 is 0, so y is going to be equal to 0. And again, if we needed to write the coordinate, it would be 2, 0, where these two lines intersect. Let's move on to another example. And I'm going to do the same process, and I'm actually going to rearrange 1. And it will be easier to have y is equal to again. So I'm going to move the minus 2x onto the side by adding 2x to both sides. So I'll have y is equal to 5 plus 2x. Then I'm going to substitute this into equation 2. So wherever you see a y, you're going to replace it with 5 plus 2x. So 6 multiplied by 5 plus 2x minus 5x is equal to 23. Now let's expand. 30 plus 12x minus 5x is equal to 23. I'm going to collect the x terms together and move this 30 over to the other side. So I'm going to have 7x is equal to minus 7. And then when I divide by 7, I'm going to have x is equal to minus 1. So now I'm going to substitute this into here. So when x is equal to minus 1, y is equal to 5 plus 2 multiplied by minus 1. Well, that's going to be minus 2, so I'll almost have 5 minus 2, which is 3. So the coordinate would be minus 1, 3. Now I'd like you to pause the video and have a go at exercise 3A on page 40. We're going to look at quadratic simultaneous equations now, and for this example we actually have one linear equation and one quadratic, and you need to use the substitution method with this. So I have y is equal to x minus 1, and then y is equal to x squared minus 6x plus 5. And because they're both equal to y, we can almost equal them to each other. So I'm actually going to write x minus 1 is equal to x squared minus 6x plus 5. I'll just repeat that. Because they're equal to the same thing, we can equal them to each other. So now I'm going to move things around. I'm going to actually move the x and the minus 1 to the right hand side. So I'll almost be left with 0 on the left hand side. So I'll put 0 so I don't confuse anyone. I'll have x squared. Now I'm going to minus x from both sides. So minus 6x minus x is going to be minus 7x. And then let's add 1 to both sides. So 5 add 1 is going to be 6. Now you never really see it like that. You see it in the other way. So I'm just going to rewrite it as this. And if you don't like the fact that I've done that because you think I'm moving it over and everything will be negative, just multiply by minus 1 if you need. So I'm going to be at this stage now. I'm now going to solve this quadratic by factorising. So I'm going to have x minus 6, x minus 1. And that's going to be equal to 0. So x is equal to 6 or x is equal to 1. Now I've got the x values, let's find the corresponding y values. So when x is equal to 6, I'm going to substitute it in to find y. Now it'll be easier to substitute into this equation rather than the quadratic equation. So let's substitute it in. So I'm going to get y is equal to 5. So here is one coordinate. Then when x is equal to 1, y is going to be 1 minus 1, which is 0. So another coordinate will be 1, 0. Just so you understand what's going on, we can look at this graphically. So here was the quadratic being x squared minus 6x plus 5. And this is the linear, y is equal to x minus 1. So straight away, if we had sketched this or plotted this so we're accurate, you can see there are two intersections, and it should be the same as what we've got algebraically. So 6, 5 and 1, 0, which is what we got over here. Now the process of substitution, we actually get another quadratic here, and the other quadratic is drawn over here. And you can see the roots. We have x is equal to 1 and x is equal to 6, and that's what we got over here. Now we have two distinct roots, and we had two intersections. We're going to see this in a bit more detail later, how we can link simultaneous equations to the discriminant and use that to help us with some questions. Let's have a look at another example. So equation 1 is linear, equation 2 is nonlinear. So I am going to rearrange equation 1. Now I'm going to make x the subject. So I'm going to move the minus 2y over to the other side. So add 2y to both sides. I'll have 8 plus 2y. And now I'm going to substitute it in to equation 2. So I'll have 8 plus 2y multiplied by y is equal to 24. Now this is just written in a weird way, but it's just an expand. So I'm going to expand this out. I'll have 8y plus 2y squared is equal to 24. Now I'm going to rearrange, put the y squared at the front and move the 24 over. And now I'm actually going to divide by 2 before I factorise because it will make it easier. Each term has a common factor of 2. Now I'm going to factorise. So I'm going to have y plus 6 and y minus 6. Sorry, y minus 2. I wrote the right thing. So y plus 6 and y minus 2. So y is going to be equal to minus 6, or y is going to be equal to 2. So let's find the x values. So when y is equal to minus 6, I'm going to substitute it into here. X is equal to 8 plus 2 multiplied by minus 6. Well, this is going to be minus 12, so 8 minus 12 is minus 4. So we've got minus 4 minus 6 as one of the coordinates. And then when y is equal to 2, x is equal to 8 plus 2 multiplied by 2, and that is going to be 12. So another coordinate is 12, 2. Let's move on to another example. So equation 1, equation 2. Same process. I'm going to rearrange the linear and I'm going to make y the subject this time. So y is equal to 5 minus 2x. Then I'm going to substitute it into equation 2. So I'll have x squared minus 5 minus 2x, and it's all squared, is equal to 3. X squared minus, now I'm going to put brackets in because there is a minus there, I can't forget about that. I'm going to expand this. If you want to do an extra step and expand the double brackets over here somewhere and then add it in, please do. I'm just going to jump from here to what the expansion will be. So I'll have 5 multiplied by 5, which is 25. Then I'll have a 5 multiplied by minus 2x, which is minus 10x, but I'll have 2 of those, so it'll be minus 20x. And then I'll have a positive 4, just going to get rid of that, I've not left enough space. Positive 4x squared, and that's all equal to 3. Now I'm going to multiply by minus 1. So I'll have x squared minus 25 plus 20x minus 4x squared. And I might as well minus that 3 over so I have everything on the other side to collect. Now I'm going to collect the x squareds together, so I'll have minus 3x squared. Then I've got a minus 25 and a minus 3, which is going to be 28, minus 28, and I'll put that over here for the time being because I've got the x term, so plus 20x, I'll write that here because it's way over there, is equal to 0. Now, I'm going to have to factorise this. There's no common factor, so I'll probably have to work with what I've got. I'm actually going to multiply by minus 1, so I can have a positive x squared to work with. So I'm multiplying by minus 1. And let's factorise this then. I'm going to have a 3x and an x. I'm going to have a minus 14 here and a minus 2 here. So I'll have x is equal to 14 over 3, or x is equal to 2. So let's go to the side here. When x is equal to 14 over 3, I'm going to substitute it into this equation here. Y is equal to 5 minus 2 lots of 14 over 3. So y is going to be equal to, well, 2 multiplied by 14 is 28. So I'm going to have a 28 over 3. So 5 minus 28 over 3. Feel free to break that down. But you should get minus 13 over 3. And then the other one, when x is equal to 2, y is equal to 5 minus 2 multiplied by 2. Well, 5 minus 4 is 1. So y is going to be equal to 1. So I'm going to have coordinates as 14 over 3 minus 13 over 3 and 2, 1. Final example, I'm going to label and then I'm going to rearrange the linear so I can substitute it into the quadratic function. So again, explain what you're doing. I'm going to make y the subject, so y is equal to 1 minus 2x. and then I'm going to sub it into equation 2. So I'm going to have x squared plus x. Now there's a y here, so I'm going to replace it with 1 minus 2x. And then there's another y here, it's y squared. So I'll put 1 minus 2x in brackets and it's squared. And that is all equal to 7. So I've got x squared plus, I'll expand this out, x minus 2x squared. And then here we've got a double brackets to expand. So again, if you need to break this down, please do. 1 minus 4x plus 4x squared you should get. Now I'm going to just move everything onto one side and collect what I can really. So let's break it down a little bit so it's not as confusing. So I've got an x squared, a minus 2x and a 4x squared. Well, 4x squared add x squared is 5x squared, minus 2x squared we're going to be on 3x squared. Now I've got an x and a minus 4x, that's going to be minus 3x. And then let's have a look at the constants. I've got a 1 and a minus 7, so I've got a minus 6 is equal to 0. Now here each term has a common factor of 3, so I'm going to divide by 3, and that is now a little easier to work with. So I'm going to factorise. X minus 2 and x plus 1. So x is going to be equal to 2 and x is going to be equal to minus 1. So when x is equal to 2, I'm going to substitute it into this y is equal to 1 minus 2x. Y is equal to 1 minus 2 multiplied by 2. So y is going to be equal to minus 3. And then when x is equal to minus 1, y is equal to 1 minus 2 multiplied by minus 1. Well, that's going to be minus 2, but I've got a plus 2 now, so it's going to be equal to 3. So therefore, the coordinates, if we need to write coordinates, are 2 minus 3 and minus 1, 3. Okay, I've got them from here and here. Now I'd like you to pause the video and have a go at these questions. Now you've had a go at those questions. Remember, they are in the notes. I'd like you to pause the video again and have a go at exercise 3B on page 41. Okay, we've got a question here. This is quite a nice question as it ties previous knowledge all together. I want you to pause the video and find the coordinates of the points A, B, C, D, E, F, G and H. You'll be using knowledge from chapter 2 and chapter 3.